Cosmic inflation, the void before everything, before time existed, before space had form, before a single particle had ever moved. There was nothing, but not the kind of nothing we imagine. Not silence, not darkness. Something stranger, a void, yes, but one buzzing quietly with hidden energy. A vacuum, but not empty. Physicists call it the false vacuum, a delicate balance of tension holding everything and nothing in the same breath. No stars, no galaxies, no laws, just potential, waiting. It wasn't peaceful, it was unstable. A cosmic stillness right before the first heartbeat. This is not the Big Bang. This is what came before, the breath before time, the whisper before creation, the moment the universe stood on the edge and prepared to unfold. The false vacuum. In the beginning, there was a strange kind of nothing. It looked empty, but it wasn't. It was filled with energy, raw, unstable, waiting. Physicists call this the false vacuum, a state where everything feels still, but it's not. Like a glass of water balanced to the brim, one touch, and it spills. This vacuum held the entire future inside it, but it couldn't last. It was like a bowstring stretched too far, like a breath held too long. The energy inside it wasn't calm, it was pressurized. The laws of physics hadn't formed yet, but the pressure was real. The false vacuum was ready to break. And when it did, it wouldn't just shake the space around it, it would create space. Stretching faster than light, tearing open the first moment of time. Everything was about to begin. 2. The flash. Cosmic inflation begins, faster than light. And then, it happened. No warning, no sound, no flash of light like we know it. Just expansion. Sudden, violent, unstoppable. In less than a trillionth of a second, the universe changed. It didn't grow slowly. It didn't build up over time. It exploded, but not in the way we usually imagine. This wasn't an explosion inside space. It was an explosion of space itself. The fabric of reality stretched outward at a speed faster than light. One moment, everything that existed was smaller than an atom. The next, it was the size of a galaxy, and still growing. This is what scientists call cosmic inflation. Not the Big Bang, but what came just before it. A moment when space itself expanded faster than any force we know. No particles, no atoms, no stars, just pure energy, stretched across a newborn universe. And in this chaotic expansion, the shape of everything to come was written. The galaxies, the black holes, the stars and planets, even the structure of your own body, all of it was seeded in that instant. It's hard to imagine something so massive happening in such a tiny fraction of time. But that's the mystery of inflation. It was quiet, it was invisible, but it changed everything. The universe didn't explode outward like a firework. It unfolded like a breath held too long, suddenly released. In that moment, the story began. The stage was set. From a place smaller than a particle, the entire cosmos took its first step forward. 3. Quantum ripples, seeds of structure. As the universe expanded at impossible speed, it wasn't perfectly smooth. Tiny, random fluctuations, called quantum ripples, appeared across space. These ripples were unbelievably small. They came from the strange, uncertain world of quantum physics, but they didn't disappear. Instead, they were stretched out, frozen into the fabric of space itself. Some areas had a little more energy, some had a little less, and that tiny difference would decide everything. Over billions of years, those ripples became galaxies. The high spots pulled matter in, creating stars and planets. The low spots became vast cosmic voids. What started as chaos turned into structure. What looked like noise became a pattern. The universe had begun writing its blueprint, not with precision, but with randomness. And from that randomness came the order we see today. Every star, every planet, began as a ripple, 4. Evidence in the echo, the cosmic microwave background. We can't see cosmic inflation with our eyes. It happened too fast, too early, too deep in time. But we can hear its echo. It's called the cosmic microwave background, or CMB. It's the oldest light in the universe. This faint glow fills the sky, left over from when the universe was just 380,000 years old. And in that glow, there are tiny variations. Small differences in temperature, only millionths of a degree. Those tiny patterns match exactly what inflation predicts. The fingerprints are still there. Proof that the early universe really did stretch in the way scientists describe. In this ancient light, the past still speaks. 5. The ongoing hunt, science still chasing proof. Even with the CMB, inflation isn't fully proven. It's the leading theory, but science wants more. Physicists are searching for something else, gravitational waves from the very first moment, ripples in space-time itself, created by the force of expansion. If we find them, it would be direct evidence, a clear signal from the beginning of everything. Scientists build massive detectors. They study deep space and deep time. They test equations and compare predictions. The pieces fit, but the final answer is still missing. Inflation is beautiful. It explains so much, but until we see every piece, the birth of the universe remains a mystery still unfolding. 6. The multiverse hypothesis. Endless bubbles of reality. What if inflation didn't stop everywhere? What if even now it's still happening, out there beyond what we can see? This idea is called eternal inflation, and it changes everything. It means our universe might be just one bubble, in an endless sea of other bubbles, each one its own universe, each one born from the same process, but with different results. Some might have no stars. Some might follow different laws of physics. Some might be lifeless. And others, full of strange versions of reality we can't even imagine. We call this the multiverse. Not science fiction, but a real possibility in modern physics. If it's true, then everything we know, our galaxies, our history, even us, could be just one note in a much larger song, a single universe, in a symphony without end. The breath that made everything. So what was cosmic inflation? A spark, a breath, a quiet start to everything. It didn't explode. It unfolded, fast, silent, powerful. From that moment came space, time, and all the rules of the universe. It made the stars, the galaxies, and eventually, you. Everything we see today began in that one instant. That breath started the story of everything. And the mystery? It's still out there. If you enjoyed this, subscribe to Cosmic Depths. The journey has just begun.